Okay, continuing on with solving quadratic equations, we're going to learn another method, and this is using the quadratic formula. We learned solving by graphing and solving by factoring. Factoring is the easiest method when you can do it. Unfortunately, most things cannot be factored, and we have to plug them into this, what is known as the quadratic formula, which is not as bad as it seems, because the a, b, and c that you see scattered throughout there just come from the quadratic equation. As you remember, ax squared plus bx plus c, and these are just coefficients or a constant that you pick off of the equation and you plug them in there. Now, a little bit of an overview. Again, we learned in our learning three methods of solving quadratic equations. The one was solving by graphing, and as we learned, a parabola is simply a curve, a bowl-shaped graph. It could be upright or it can be inverted. It can be wider or narrower. But in any event, where it crosses the x-axis is called the solutions. And another way to find where it crosses was when we solved by factoring. Now, actually, most equations will not be factorable, so then we'll have to use a quadratic formula. But let's go back and do a refresher on graphing. If we had y equals x squared plus 2x minus 3, we said, well, to help us graph, we'd find the axis of symmetry, which would be at x equals negative b over 2a. Okay, a in this equation is equal to 1 because x squared is the same as 1x squared. B is equal to 2, and c is equal to negative 3. Plugging those in, we have negative, take out b and put in 2 over 2 times 1, which is just equal to negative 1. So our axis of symmetry is at x equals negative 1, which again helps us graph this more easily, because the axis of symmetry is the line that would cut the parabola in half. So you might want to take a minute and draw an x and a y axis on your study guide. And our axis of symmetry would be at, again, x equals negative 1. So this will help us choose our values. We'll put in, or the values we'll put in for x, we'll put in negative 1. And then we'll go one right and one left. So that would be 0 and negative 2. And 2 right would be 1 and 2 left would be negative 3. And if we put these values in, so that'll be 1 minus 2 minus 3, which would give us negative 4. If we put in 0, we get negative 3. And because it's symmetrical, we expect negative 2 to also give us negative 3. And indeed, it does. And putting in 1, we get 0. And we'll get the same value if we put in negative 3. Plot the points. And there's our parabola. And note where it crosses is right at where x is equal to 1 and -3. These are called the solutions or roots or zeros. And if we factor x squared plus 2x minus 3, remembering back to our solving by factoring, we get the same solutions. Now on this page, I have another one that you can try on your own. Ultimately, when you graph it, this will see if you've learned all your graphing techniques like axis of symmetry and the shortcuts to graphing. And when you complete this, you should only end up with one solution, and that solution will be 2. So on your own, go back and graph that, learning our graphing techniques, and see what does a parabola that only has one solution look like. How could it only touch across the x-axis once? And you can do that now and pause if you want, or we can go on and we'll talk about the quadratic formula. Okay, many times a graph will not cross at an integer, or might not cross or touch at all. And these are the type that require using the quadratic formula. For example, x squared minus 6x plus 6 is not factorable. If you graphed it, you would see that it appears to cross somewhere between where x is equal to 1 and 2 and somewhere between where x is equal to 4 and 5. So you have to plug this into the quadratic formula. Again, it's not a pretty looking formula, I guess because of the plus and the minus and the large radical, but it's not difficult. You just have to pick off your values of a, b, and c. In this case, a is equal to 1, b is equal to -6, and c is equal to 6. And simply plug in the values. And whenever you substitute in values, please put what you are substituting in, the numbers, the values, in parentheses. So we take out b and put in -6 plus or minus the square root. Take out b and again make sure you put in parentheses -6 minus 4. Take out a, put in 1. Take out c, put in 6. And it's doing careful arithmetic and watching your signs. Like a negative is a +6. Plus or minus 36 minus 24 is 12. And again, what you learned about simplifying radicals, the square root of 12 breaks into the square root of 4 and square root of 3, so that becomes 2 times the square root of 3. And oftentimes you won't be able to simplify any further, but in this case, since 2 goes into both 6 and 2, you can further reduce it. 2 into 6 3 times, and then 2 into 2 once. So it's just 3 plus or minus the square root of 3. And you'll just leave your answer in this form. If you're curious, you could approximate what it is. Well, the square root of 3 is approximately 1.73. So if you go 3 plus, it's going to cross around 4.73. If you go 3 minus the square root of 3, it'll cross around 1.26. But you're never going to calculate this. On all standardized tests and textbooks, you just leave it in this form here. So in summary, what you do is you just decide what A, B, and C are, which is just a matter of going and picking off the coefficients and the constant. You plug them into a formula, and notice, be very careful with your minus and negative signs. And if possible, simplify the radical. So again, not as bad as it looks. You just have to be careful with your arithmetic.